don't know.
25 mLs, 1 in 200 dilution.
So
So V1 divided by V2 equals V1 divided by V2.
I don't know.
I mean V1 divided by C1, V2 divided by C2. And all you do is divide 25 by 200. Which equals
0.125.
okay, 0.125 mLs. So where's our metric person? Where's the metric girl? Oh, there's
Teacher.
So how much is 0.125 mLs?
Well, I remember 1 cubic meter is 1,000 ml.
1 cubic.
1 cubic meter is 1,000 mLs. So, oh no?
Isn't 1,000 milliliters equals to 1 liter? So then you would...
So what are you asking for? How many liters?
0.12, he said, he came up with the answer, and he's correct. All we have to do is divide 25 by 200, based on the formula, comes up to 0.125 mLs.
Right.
So my question is, 0.125 ml is how much?
In liters?
And what?
In liters?
Yeah, milliliters, right? It's 0.125
Times 10.
milliliters. So we have to think now, a microliter, how much microliter is that?
You just add 3 zeros. So it's 0.0000125.
Zero makes milliliter.
0.25 times.
How many microliters are there in 1 ml?
Isn't it
It's 1,000, right?
1,000.
Yeah. So you add 3 zeros, right?
So 0.125 is how much?
125
125 microliters.
Oh, right, that's true. Okay.
Micrometer? 125.
Microliters.
Yes, microliters, right? That's a millionth of a liter.
I have a question. Every time you ask, like, what is such and such milliliters, you're going to want the answer in microliters?
Not really, because we're going for mLs, right?
Right.
So, yeah, I mean, you're
25
going,
ml.
right? It's not 5 ml. If I say, how much is 5 ml? Well, you say, well, just take something and measure out 5 ml. But here we're saying 0.125 mLs. We can't measure that. We can, right? It's hard to measure that. So if you break it down, right, into microliters, then it's easy to measure.
Okay.
Okay? Doesn't that make sense?
Yeah.
That's why we have the metric system, right? The 1 liter is how much in terms of length? You were saying 1 meter square is 1 liter. 1 meter square is that big?
No,
That's
cube,
like-
I think.
Yeah, a meter cube.
1 meter cube is 1,000 liters, right?
1,000 liters.
Yeah.
Okay, that's different. So how much is 1 liter?
So 1 liter is 0.001 cubic meters, or 1 cubic millimeter, right? 1 liter is 1
Who's got the answer?
cubic.
You want to know
And
what
milliliters?
milliliters cube or like
Well,
one
yeah,
milliliter?
in the metric system, right? We're using, it starts from deci, right? Centi, milli,
Then
micro, nano, pico, femto, atto, right? You can keep going. Keep adding 3 zeros. So which one square gives you a liter?
the milliliter.
No, 1 ml, we know that. We're doing that right now. The one before, which is what?
Deci, I think.
Deci. 1, right? Decimeter square gives you a liter.
Right.
Okay, make sure you guys go back and look at the video. The video on YouTube, they show you, they give you a nice explanation. And they say 1 cc gives you 1 ml. And 1 millimeter cube equals 1 microliter. So when you're reporting cubic millimeter, it's actually, and we're saying there's 5 million cells in 1 millimeter cube. That's 5 million cells in 1 microliter.
Okay.
All right? So it's going to be to your help, because when you go in clin chem, there's a lot of calculations again. Some of you are probably in there. You're going to do dilutions, and we're going to be doing a lot of it here also. So you want to go back and make sure you key in on these little metric things, right? We're not going high. We're pretty much stuck in the micro, and so on. The micro level, micro. We're not going like nano and pico. But in the lab, they go up to 10 to the minus 12. That's how much plasma or serum is taken by the machine. 1 femtoliter, 10 to the minus 12 of a liter. The machine will pipette out to do certain tests. So we do, in our field, go down lower than the micro level, but you should know and do that. It's good to just memorize, right? If you go up, you have what, hecto, kilo, and so on, right? Yeah. All right, so we need, so pipetting, everybody's going to have to learn the pipetting. So this is your pipettement, right? And it says 200. 200 means what when you see the 200 there? As opposed to this one says 1,000. What does that mean?
Microliters?
Microliters. So this can only measure up to 200 microliters. This will go up to 1,000 microliters. So I need 125 microliters. Which one should I use? The 200 or the 1,000?
200.
Use the one that's closest to your volume. That will be more accurate, right? And of course, there's different tips that it comes with, and it has an ejector here. And so you put your tip on. Our blood we buy, right? So these are controls that we can use on the machines. It's commercial blood, but you still have to protect yourself, right? So we buy it with different levels of control, and the levels are usually, you get a low abnormal, you get a high abnormal, and you get a normal. And you will see on there L, N, or H. Okay? So the counts are different in each. So these we know when we buy them, the insert give us the answer, what the counts are. So it's extremely accurate. So when you count, your number should come very closely to match what they're telling you it is. So these are used in some of our cell counters for doing a CBC, the blood machines. And we use it as controls. So in the morning, you warm this up, take one out, and put it on the machine. It needs just a little bit only, right? And we will do the test and spit out all the results, and it should match this. Because the companies, they send you a disk, it goes into the machine, and it put all the parameters in there. So now when you run it, the machine, you tell the machine which samples you're using, whether you're using normal, low, or high, and when you ask for it and you run the test, it matches it to the parameters given, and it will tell you whether it's good or if it's out of range or and things like that. And so we buy this. So this is extremely accurate. It's slightly different from real blood because it's commercial blood. So you'll see we'll do a finger stick on someone next time, and so you'll see the difference from this to that. But the cells are very obvious. The white cells in here are actually taken from a different animal when they use it. So it's much larger than a human white cell. So it's easy to count and differentiate. And so this might not be human, it might be from some animal. but it's comparable for the counting. And the machine recognizes also. So to make up our solution, right, so we need the blood. I'm going to make sure, here you guys can mix it as you go, because they're sitting in the refrigerator. So we need, when we do for RBC, we need what? Saline. What happens if we use water to make up our dilution? Water will do what to red cells? Why?
Because the hydrogen in the water is going to.
Water is said to be hypotonic or hypertonic to RBC? Hypotonic. What is the concentration of salt in RBC? The percent for sodium chloride. If you go to the hospital and you look at a saline, you know, they give people saline. What do you think it's going to say on the bag for sodium chloride? Right. So RBC, the concentration of sodium chloride in an RBC is 0.85%. So if we make a 0.85% solution, this is said to be what to RBC? Isotonic. Isotonic. Water will be what? Hypotonic, which will cause the RBCs to swell and burst, like he said. So you have to make sure when you do your dilution, and you will all do this, right? Make sure you do not pick up water, or else when you load your chamber, what's going to happen when you look in there? It's not going to be anything. It's all hemolyzed. Okay? So we use a volumetric flask to do dilutions because it's, right? You got to be very accurate, and you actually fill it. You've all seen volumetrics, yes? Yes? So so what I do is put some saline in there. All right, about half or so, okay? And then I'm going to add my blood. Who's got my... Okay, so I set it, if you see the reading, right, it's set for, so it starts 1 at the top, 2, 5. So you need to play around with this when you don't have any time to see how it changes. Maximum is up 200 liters, right? So we do only have 25 microliters. So I set it to 125, right? This is all mixed, okay? So to pipette, right, you see it goes, and then it goes an extra little bit. Do not, when you depress this, don't go all the way down when you're picking up. So you depress, you put it in, right? You don't want it to touch the bottom, just slightly off the bottom, and then you release slowly, because you don't want bubbles to get in here, okay? So usually you can get a Kim wipe and you can wipe that off. If you do it carefully, you don't need to do that. So put it in, right? And you squeeze, right? Make sure it all goes in. And then that's when you press the extra little bit on the, right? The plunger. And that will make sure that everything in here is dispensed in here. All right? And of course, there's the eject button on that. Okay, can you close that up for me back? So now we have to fill it up. You see the blue line? Everyone see the blue line right there? So we have to fill this up now with the rest of it with saline until. So you don't want to go over. If you go over, what happens? Too much, yes? Do it all over again. And, yeah, and so you just mess it up, and then you have to do it all over again. Do not pour the blood in here without adding some saline. So it's good to have a little bit of saline in there.
Oh, so
right?
It doesn't matter the measurement?
Right.
Okay.
Yeah. So this, we can mix this up, right? You can use a parafilm. So we have parafilms, right? So we can seal this up, right? Make sure it's not leaking, right? And then you can make sure this is mixed correctly. Now when you take from this, you're going to make sure it's mixed also, okay? So I'm going to pour this. Give me an Meyer flask, a 25 ml flask in there, so it has a wide mouth.
You said 25 ml?
Yeah.
So is the top number the 100, or is it?
Well, what is the volume on that?
It says 200 or 1,000 micrograms.
Say again?
200 to 1,000.
Yeah, that's 1,000. So the top number should be a 1, and the rest are zeros below it. That would be 1,000 ml.
Okay.
All right, so I'm going to pour this in here so everybody will take from this. Okay? It's easier to just get a pipette and do in here and take from that. All right, so bring your chambers now, and I'm going to show you how to load.